Now we have to create the liquid mesh, which is based on the particles we created. In this case, it is useful to set the cache as modular. In this way, we can separately bake the single components, such as liquid, mesh, and particles. Remember to set the as-resumable property. Also, set the end value to 150. Now, check the mesh attribute and open the related tab. For the moment, we can leave the default values. Now you can bake the liquid particles. When it is completed, bake the mesh. In order to better see the mesh, we can restore the right viewport visibility for the domain. Previously, we set the domain viewport visibility as wire in order to see the particles inside the domain. But now we have the mesh, so it can be set back to textured. You can set the wire display option for the collision object. When we play the simulation, the liquid goes inside the boat, so it seems that the collision object is not working properly. This generally happens when there is not a proper detection of the collision margins. First of all, you have to consider that the collision detection is also related to the resolution of the simulation. That is the resolution divisions property. Basically, the higher the resolution, the more accurate the collision detection. And this because the resolution is the lens through which Blender looks at the simulation. So, free the baked data and increase the resolution to 64. It will take longer to bake, but this is useful to have a better view of the mesh. The collision seems to be better. Some liquid still passes through the boat, but to a lesser extent than before. Here you can see the difference. Another way to improve the collision is by increasing the surface thickness of the collision object. Basically, this extends the collision surface around the object. Let's try a value of 0.5. Now the collision is even better, and only a small portion of liquid flows inside the boat. However, the surface thickness doesn't have to be too high. Otherwise, it would be clearly visible the gap between the boat and the water. In addition, as told before, if you have a fast-moving object, you can also increase the sampling substeps in order to have a better detection of the collision. In our case, we can leave this at its default value. Finally, we have another option to take the liquid outside the boat, and we can do that by selecting the option Delete an Obstacle. This forces the simulation to delete the liquid particles and mesh inside an obstacle. And this is the final result. Now it should be easier to understand why we chose to start the simulation with the boat outside the water. In this way, Blender can better calculate the collision with the boat and keep the liquid outside it. So, at this point, we have a proper collision and some waves around the boat. However, the simulation still lacks energy and we have no splashes. In order to add energy to the simulation, we have to add a guide object to the scene. As saw before, a guiding object is the one that adds a velocity component to the simulation. So, the best way to do that is simply by duplicating the collision object. In this way, it already have the proper mesh and animation. Duplicate the cage and rename it as guide object. Then, change its effector type to guide. In order to compute a guide object, we have to activate the related property in the domain. So, select the domain and check the guides option. Here you have to select effector as the velocity source. Now, when Blender computes the animation, it also takes into account the guide object. This slows down the computation time, but it leads to more interesting results. First of all, you have to bake the guides. Then, as usual, the liquid in the mesh. After the baking, you can clearly see the difference. Now we have different ways to adjust the energy of the simulation. In the guide object, there is the velocity factor property. This is basically a multiplier of the guide object velocity. We also have a velocity factor property in the domain object. This is also a multiplier factor, but in this case, it affects all the effector inside the domain. Consider it as a global multiplier. We can increase this factor in the guide object. For example, let's set it to 2. Then, bake the simulation again. The energy of the impact is now too strong. However, you got the point. You can precisely adjust this value in order to reach the effect you want. We can leave this value to 1. Consider that the final result also depends on the simulation resolution. So, if you increase or decrease the division's value, the result may be different. Now we have to consider the resolution and quality of the liquid mesh. The resolution is clearly too low. We can smooth the mesh by clicking with the right mouse button and choosing Shade Smooth. But this has no impact to the resolution itself. As we already saw, the first way to increase the resolution is with the global divisions. And, for the final render, a value of at least 128 is strongly suggested. However, we can also increase the mesh resolution with the uppers factor. This increases only the resolution of the mesh, based on the base resolution of the domain. We can clearly see the result in these examples. Here we have a liquid simulation with an uppers factor of 1. Here, the same frame, but with an uppers value of 2. The liquid mesh and particles have a higher resolution, although the base resolution of the domain is the same. So, we can test the simulation with an uppers factor of 3. The mesh seems to have a higher resolution. Another factor is the particle radius. When we increase the uppers factor, the mesh around the liquid particles becomes smaller. You can compensate by increasing this value. And the combination of these two factors is strictly related to the result you want to get. Here, for example, we have a liquid particle and, around it, the related mesh, with a particle radius of 2. And here, the same frame, but with a particle radius of 1. As the mesh radius was too small, the liquid particle wasn't either meshed. So this is another factor you have to carefully consider. Now it is also clear why it's useful to have a modular baking of the simulation. We can test different values of the mesh, without having to bake again all the components. You can simply free the mesh, set other values, and then bake again only the mesh. At this point, it should be clear to you that the final resolution is a combination of the global grid divisions and the mesh resolution. For our final render, we decided to set the grid divisions to 256 and the uppers factor to 3. Finally, we have to consider the smoothing positive and negative attributes. In this first example, the properties are at their default values. If we increase the smoothing positive factor, the mesh is smoother, and this can lead to losing detail. On the other hand, with higher smoothing negative values, the mesh is sharper, but this can lead to have more artifacts. In most of the situations, we can leave these properties at their default values. Finally, Remember to activate the Use Speed Vectors property in the Mesh options. This is useful to add some motion blur to the liquid, as we'll see later. Now it's time to have a test rendering of the scene. But before doing that, we have to set up a proper illumination in the water material. First of all, delete the default light. For the global illumination, we could use an HDR image, but this time, we want to use the sky texture that we already have in Blender. Open the World tab, and in the color setting, choose Sky Texture. As default, we have the Nishida sky map that can be used both as global illumination and as background. We'll adjust the parameters in a moment. We have to create the material of the water. This is really simple. Select the domain object and open the Shading tab. Create a new material. For the water material, we can simply use a glass shader. So, delete the principled shader, add a glass one, and connect it to the surface input. We have to change the index of refraction value to 1.333, which is the index of refraction of the water. For a better realism, also add a volume absorption shader and connect it to the volume input. Now, be sure to have Cycles as rendering engine, and click on the Viewport Shading button. We have to hide the water object, which is the source of the liquid. Indeed, the water itself is created in the domain object. Also, disable the View and Rendering option for the collision and guide object. Now we can adjust the sky texture in order to get the illumination we want. As you can see, the volume of the water is very small. This is the reason why we place the camera, in order to frame a small portion of the scene. As told before, this is due to the fact that we want to take the domain object as small as possible, at least for this exercise. Otherwise, the computation time would be too long. It is also clear that the resolution of the water is too low. You can clearly see this in the bubbly shape of the splashes. This is the reason why, for the final render, we have to increase the resolution divisions. But if the domain is too big, we should increase the divisions too much, in order to have the same resolution compared to a smaller domain. We can also improve the rendering of the water in two ways. We can add a plane below the water, in order to mimic the seabed. It is also better to add a subdivision surface modifier, in order to get a circular shape. In this way, we don't see the corner of the plane, and it is closer to a real horizon line. This plane is useful to avoid the glass material to reflect the color of the sky texture below the water. And we can also change the color of the seabed to get a better result. In addition, we can slightly change the absorption color of the water, in order to mimic the real behavior of the water. However, we still have the problem of the small size of the domain object. Unless you frame the view with a very close-up view, its border is clearly visible. We can mitigate this problem by adding another plane, also this time with a subdivision surface modifier. The idea is to extend the boundaries of the water beyond the domain object. But, in order not to look completely fake, we have to follow 3 steps. First of all, we have to place and sculpt the plane, in order to be roughly at the same level of the edges of the domain. So, move the plane along the z-axis. Then, increase the subdivision's value, and apply the modifier. Now, switch to the sculpt mode, and sculpt the plane in order to have a similar shape as the border domain. You can subdivide the mesh in order to have a higher resolution. Now, assign the same water material and render the scene. The problem is that the difference with the water is clearly visible, and it will be more visible when we'll increase the resolution of the water mesh, as it will be a more rippled water. So, the second step is to add a displacement modifier. This is due to the fact that we want to add some ripples to this ocean object, in order to have a closer match with the shape of the simulated water. Create a cloud texture, and adjust the scale and strength until you get a proper surface. However, you will never get a proper match of the two surfaces. This is the reason why we have the third step, which is to add a proper amount of depth of field to the camera. Let's frame the camera in this way, in order to see a portion of the extended water. Now, enable the depth of field, and add an empty object to be used as focus distance. Then, lower the value to something like 0.2. In this way, thanks to the blur in the background, the edges of the fake sea are less visible. With all these tricks in mind, we can finally move on to the last step, which is the creation of the spray and foam particles. Before adding the spray and other particles to the simulation, it is important to cache the other components in their final version. I mean, we have to be sure to have the proper guide velocity for the collision, the right animation and density of the liquid particles, and, finally, the proper resolution of the liquid mesh. This because the simulation of those particles may require a lot of time and memory, especially if we want to add all the three types of particles. But the quantity and distribution of those particles relies a lot on the number and velocity of the liquid and the resolution of the mesh. So, in order to have a proper calculation of spray and other particles, the other components have to be in their final state. Now, open the Particles tab. Here we can select the particles we want to add. We can add spray, foam and bubbles particles. Spray particles are those that fly above the liquid surface. Foam particles are those that move on the liquid surface. And, finally, bubble particles are those that move inside the liquid. The first thing you can do is to select all these particles types and bake this component. Now, it can be useful to take a look at each type of particles in order to see their distribution. In order to do that, we have to hide the mesh. You can do that by unchecking the mesh component. But now we see a box that represents the domain. So, open the Object Properties panel and set the viewport visibility as wire. Now, open the Particles Property panel. Here we have all the particle systems of the simulation. You can hide or show any particle system in order to see the number and distribution of the related particles. It is also clearly visible that the bubbles is the particles system with the largest number of particles. In the Particles Properties, we can also change these parameters in order to increase or decrease the total number of particles. These properties are not easy to understand and how they will impact on the simulation. However, consider these parameters as a way to increase or decrease the probability to create the spray, foam and bubbles in relation to each of the properties that you can find in this panel. In general, you can leave these attributes at their default values. As told before, the total number of particles is also related to the number of liquid particles and mesh resolution. And this is the reason why it is better to bake these particles only when we are satisfied with the other components. In this case, we found that the bubbles particles are the most expensive to compute, and this is due to their large number. On the other hand, they are less visible as they are inside the water, and generally hidden by the other particles. So, for the final rendering, we decided to disable their computation. Now we have to create the particles themselves in the material. Add a new icosphere, and set the subdivision's value to 1. We have to take the face count as low as possible. You can move it away from the scene. Resize the object to be very small. Rename the sphere to spray. Create a new copy and rename it as foam. Now, let's create the materials. Select the spray particle and create a new material. This can be a simple glass shader. Set the index of refraction to 1.333. For the foam, we can mix the glass with a diffuse shader in order to give a slight appearance of less transparent material. Now we have to assign these objects to the related particle system. Select the spray particle system and, in the Render tab, set the render property to Object. Then, select the spray mesh. Do the same for the foam. In the final simulation, it is probable that we'll have a great number of particles, and this can slow down a lot the viewport. So, it's better to set the viewport display as point, and, eventually, reduce the number of particles. Now we can preview the scene. Before doing that, we have to enable the mesh and set its visibility to textured. Then, click on the Viewport Shading button. However, as we change the viewport visibility for the particles, we don't see them in the preview, but only in the final render. For this exercise, I set back the visibility also for the viewport display. Now we have to set a proper size for the particles. Basically, you can change the scale factor, both for the spray and the foam, until you get a realistic result. In some cases, you could get a strange pattern repetition for the particles. In order to avoid this, we can use a simple trick. Create a collection both for the spray and foam particles. Then, duplicate 3 or 4 times the particles. Open the Edit mode and move a bit each mesh. Then, in the particles properties, assign the related collection as object source. Finally, select Pick Random for the distribution. This is a simple way to break the pattern repetition you could have. As a last step, we have to add some motion blur. Consider that, in the liquid simulations, you can't add motion blur simply by activating the related property in the render properties. It has to be generated in the compositing process. So, the first thing to do, as we mentioned earlier, is to activate the Use Speed Vectors property in the domain settings. If you didn't do that, you have to free the mesh and bake it again. Then, open the Layer Properties tab and check the Vector attribute. Also, check the denoising data. Now open the compositing view. Here we have to add a basic compositing setup that is useful to add some motion blur and also to reduce the noise. Click on the Use Node checkbox. But before using the compositing, we have to have an image to work with. So, simply render the scene. In this example, we only have few particles. This is useful to speed up the rendering. Now, add a viewer node. Then, add a denoise filter and connect the attributes as shown here. Now, add a vector blur filter and connect the nodes in this way. As you can see, the particles now have some motion blur, and this is useful to add realism to the scene. It is generally necessary to lower the blur factor. Also, in some cases, we have better results with the curved option. In this way, we not only added some motion blur, but we also denoised the rendering. So, we can render the scene with a lower value for the rendering samples, and this saves us a lot of time. Now it's finally time to render all the animation. I suggest to set the rendering as an image sequence. In this way, you can always stop and resume the rendering. This is the final rendering we made. You can try different camera views, illumination setup, and global rendering options in order to get the best result for you. We hope you enjoyed the course, and if you have any questions, feel free to post them in the discussion section of the course.